Theorem 10.9 states, two chords are congruent if and only if they are equidistant to the center. Now, again, this is a biconditional statement, meaning that there's really two ways to interpret this theorem. One reading that this is if P then Q, which says if two chords are congruent, then they are equidistant to the center. If we were looking at the theorem in this case, we would know that this chord EF is congruent to this chord CB, and because those two chords are the same exact length, we would know that this distance AG is congruent to AD. Now, one thing to note about this is that we can consider this line to represent the distance because of the 90-degree angle here. We have to remember that when you're talking about the distance between a point like the center and a line like a chord, that line must make a 90-degree angle, otherwise it cannot be considered a distance. If we look at the second reading of this, if Q then P, it would read, if two chords are equidistant to the center, then the chords are congruent. Again, in this case, we would know that the distances AG and AD are congruent to each other, and because these two chords are equidistant from our center A, that would tell us that this chord EF is congruent to this chord CB.